Welcome to Chem Talk, Breaking Down the Basics series.
Hello everybody, my name is Julian and today we will be going over electron geometries versus molecular geometries. I've written out a few Lewis dot structures here. In a past video I've gone over how to do that, and we can use these Lewis dot structures to determine the electron geometry and then further the molecular geometry. Now electron geometry is purely concerned with how many electron domains there are. So for the purposes of electron geometry, this, what we call single bond, this double bond, and these lone pairs are all considered just one electron domain. Now, for electron geometry and molecular geometry, we only care about the central atom, where everything is bonded to. So for this right here, which is CO2, carbon dioxide, this central carbon has 2 electron domains, which means it would have a steric number of 2. So the electron geometry would simply be linear. This right here, this boron trichloride has 1, 2, 3, so a steric number of 3. This methane, CH4, has 1, 2, 3, 4, steric number of 4, or tetrahedral. H2O, even though it's only bonded to 2 atoms, these 2 lone pairs are also considered electron domains, so we have the steric number of 4. And this boron tetrafluoride, bromine tetrafluoride, sorry, BrFl4, is bonded to 1, 2, 3, 4 atoms, but then it has 2 lone pairs. So it has a steric number of 6. Now, if we were to look at all of these from a pure electron geometry standpoint, they would all be based on the number alone. I'm going to show you a quick graph. So let me share the screen so you can see this. Here we go. Now, if you look right here, the 2 would be linear. Oh, you can't see the board. The 3 would be trigonal planar. 4 would be tetrahedral. 5 would be trigonal bipyramidal, so you can think of 2 triangular pyramids on top of each other. And 6 would be octahedral. Now, that is the pure electron geometry. But if we go to the molecular geometry, we have to take into account the difference between atom to atom, so a molecular bond, versus just a lone pair. This graph will help you differentiate, and we have these available at the Science Tutoring Center at Palo Alto. But let's go back to the board so I can point out these differences with a little more detail. So I'm going to erase some of these up here. Now you might notice that this is bonded to 4 atoms, so it will be simply a tetrahedral molecular geometry. But this right here is bonded to 2 hydrogens and has 2 lone pairs. So instead of being a tetrahedral geometry, that would be its electron geometry. For its molecular geometry, we would instead describe it as what we would call a bent electron geometry. So it would look something like this, where this area right here would represent the L and these would be the 2 H's. And if we look at our graph, we will see that. So I'll go back to here. If we look at a total steric number of 4, but with 2 lone pairs, that gives us a bent molecular geometry. Now you can do this yourself. So if I go back to the board, you can assess right here, this bromine tetrafluoride has a total steric number of 6, but 2 lone pairs. On your own, use that graph and try to figure it out. Thanks for watching. Bye-bye.
That's a wrap for today's episode of Chem Talk, Breaking Down the Basics series. Thanks for watching. If you enjoyed this video, don't forget to hit that subscribe button. Until next time, keep learning, stay curious, and we'll see you in the next Chem Talk, Breaking Down the Basics episode.